same fiery explosion that propels a rocket into space is quietly happening hundreds of times every minute, right under your car's hood. Welcome to the explosive world of the internal combustion engine. It's the mechanical heart of most vehicles we see on the road today. Whether it's your everyday sedan or a thundering supercar, combustion is the invisible force driving it all. And today, we're taking you inside the fire, the fury, and the fascinating mechanics of the combustion engine. Before we get started, don't forget to subscribe so you never miss a deep dive into the world's most powerful machines. How a combustion engine actually works. Let's strip it back to the basics. The combustion engine runs on a simple but powerful principle. Explosions create motion. In scientific terms, it's the controlled ignition of fuel inside a closed chamber. And that explosion moves a piston, which in turn powers your wheels. Imagine this. You mix fuel with air, compress it tightly in a small space, and then ignite it. That burst of energy pushes down a piston inside a cylinder. That piston is connected to a crankshaft, which rotates as the piston moves. Multiply this by several pistons working in perfect harmony, and you've got a powerhouse of continuous rotational motion ready to move your car forward. This cycle, intake, compression, combustion, and exhaust, repeats hundreds or even thousands of times per minute. And that's how your engine turns a gallon of gasoline into a morning commute or a weekend road trip. The main parts that make it all happen. Let's pop the hood and look at the real heroes behind this process. The internal combustion engine is a symphony of moving parts, each playing a vital role in this fiery performance. 1. Cylinder block. This is the main body of the engine, where everything takes place. It houses the cylinders where pistons move up and down. 2. Pistons. These are cylindrical pieces of metal that move up and down within the cylinders. They're directly pushed by the combustion explosion. 3. Connecting rods. They connect the pistons to the crankshaft, transmitting the force from the explosion to rotational energy. 4. Crankshaft. This long, rotating shaft converts the piston's up and down motion into the rotational motion that powers your wheels. 5. Cylinder head. Sitting on top of the cylinder block, it contains the intake and exhaust valves, spark plugs, and sometimes the camshaft. 6. Camshaft. It controls the opening and closing of valves. It's synchronized with the crankshaft through a timing belt or chain. 7. Spark plugs. These ignite the fuel-air mixture in gasoline engines. Without them, there's no explosion, just silence. 8. Valves. Intake valves let air and fuel in. Exhaust valves let the burnt gases out. Timing is everything here. 9. Fuel injectors or carburetor. These systems control how much fuel enters the cylinder and mix it with air for proper combustion. 10. Oil system. Reduces friction and prevents the engine from overheating or locking up. 11. Cooling system. Uses water and coolant to regulate engine temperature, keeping those metal parts from melting. Every part has to function with mechanical precision. One mistimed spark, one clogged valve, and the engine could stall, misfire, or fail altogether. Think of it like a mechanical orchestra, where every component must play in sync for the music to roar. Types of combustion engines. Now, let's talk variations. Combustion engines come in different flavors depending on how they handle fuel, air, and ignition. And no, they're not all the same. 1. Spark ignition SI engine. This is the gasoline engine most of us are familiar with. It uses a spark plug to ignite the fuel-air mixture. 2. Compression ignition CI engine. These are diesel engines. Instead of using a spark, they compress air until it's hot enough to ignite the fuel when it's injected. 3. Two-stroke engine. It completes a power cycle in just 2 movements, up and down, of the piston. Lightweight and powerful, but less fuel efficient and more polluting. 4. Four-stroke engine. This is the standard for most modern cars. It takes 4 strokes, intake, compression, power, and exhaust to complete one cycle. These engines differ in design, power output, fuel efficiency, and maintenance needs. Some are designed for speed and acceleration, others for endurance and torque. Choosing the right one depends on whether you're racing down a track or hauling a trailer up a mountain. Engine classifications. Not all engines are created equal, not even in layout. How an engine is mounted and how many pistons it uses dramatically affects how the car performs. By location in the vehicle. 1. Front-mounted engine, the most common setup. It provides better traction for front-wheel drive cars and makes maintenance easier. 2. Mid-mounted engine, placed behind the driver but ahead of the rear axle, often in sports cars for better weight distribution. 3. Rear-mounted engine, located behind the rear axle, like in some Porsches and older Volkswagen Beetles. Great for traction, tricky for handling. By number and arrangement of pistons. 1. Single-cylinder engine, mostly used in motorcycles or lawn mowers. Simple, cheap, and efficient for small machines. 2. Inline engines, I3, I4, I6 pistons are aligned in a single row. Common, compact, and easier to manufacture. Inline 4s are the workhorses of the car world. 3. V engines, V6, V8, V10, V12 pistons arranged in two angle banks, forming a V. More power and smoother operation, often used in performance and luxury vehicles. 4. Flat or boxer engines. Pistons lie flat, facing away from each other. Found in Subarus and Porsches. Low center of gravity improves handling. 5. W engines, W8, W12, W16 complex and compact. They're essentially two V engines fused together. You'll find these monsters in cars like the Bugatti Chiron. The more cylinders you add, the smoother and more powerful the engine becomes. But it also becomes heavier, thirstier for fuel, and more expensive to maintain. It's all a balance between power, efficiency, and design purpose. Combustion versus the future. As much as we love the thunder of a V8 or the whine of a turbocharged inline 4, the reign of the combustion engine is facing a serious challenger: electric power. EVs are cleaner, quieter, and require fewer moving parts. Governments are pushing for cleaner alternatives, and manufacturers are shifting gears. But make no mistake, combustion engines aren't going away overnight. They're evolving. Think hybrid systems, turbocharging, cylinder deactivation, and cleaner burning fuels. Until the electric revolution becomes fully mainstream, combustion engines will continue to power the world in ways both innovative and iconic. Whether you're a gearhead or just curious about what's under the hood, understanding the combustion engine is your first step into the world of machines that move us. If you found this breakdown helpful and eye-opening, hit that subscribe button so you never miss our next mechanical deep dive. Stay curious, stay fired up, and keep exploring the power that drives the world.